In this problem, we consider how a structure of two triangles symmetrically arranged deforms when pushed from both sides. It then behaves like a pantograph, which is shown in the illustration. You may just imagine that the distance between D and B expands. Then, now a member is placed between the points that is about to expand. In this problem, the elongation of the member BD is required to calculate. When we apply a load P, axial force is generated in the member BD. So, we need to find the load acting on the member first and derive the elongation of the member BD. This is a statically determinate problem. The first step is to find the axial force acting on the member BD with respect to the balance of the loads. The problem is solved by considering the balance of the loads acting at B or D. We first find the axial forces acting on AD and AB. It is derived from the balance of these horizontal forces. In this problem, we may focus on one of the left and right triangles, which results in the same result. Here, we are exploring the axial forces acting on AD and AB, instead of those on DC and BC. Then, the balance of the force at point D is obtained and we can derive the axial force generated in the member BD. When this structure is compressed at these points, AD and AB are exposed to a compressive force. Since the 2 points B and D move apart, only the center member BD is stretched. So, the load acting on the member BD is positive. Then, we get the relationship QBD equal to P and derive the elongation as the equation. I have explained in detail how to solve the exercise problem, but you may challenge the problem by yourself once. Then you may feel this is a simple procedure to get the solution.